Hi everyone, a very good morning to all of you. Today we are going to study about the question number 31 related to galvanometer, moving coil galvanometer, and how we can convert it into voltmeter and ammeter. Now, to understand first, we need to understand what is a galvanometer and its current voltage sensitivity. See, it is a device. So galvanometer is nothing but it is a device to measure. It is a device to measure current. Now it is like between the two magnets, we will arrange one coil with some number of turns n, and we will pass some current through it which is to be measured. Then the magnetic moment of the current loop is Ia. As there are number of turns in Ia, then torque tau equal to mb sin theta. So torque tau equal to NIAB sin theta. But the shape of the magnets we will arrange such that always the magnetic field is perpendicular to the magnetic moment. Nothing but always the magnetic field lines parallel to the plane of the coil, so that the torque value will become NIAB. Now due to this magnetic torque, the coil starts rotates. Like here we will arrange one spring, so that as the coil rotated by some angle which we measure using the reflection method, here we will arrange one mirror. Now here as the coil, cylinder attached with the coil rotated, the spring attached at the bottom got twisted, so that there is a restoring torque will develop, that is C theta, where C is torsional constant or torque constant. Theta is the angle through which it got rotated, so that NIAB equal to C theta. This is the formula. Now current per unit deflection I by theta equal to C by NAB. This is called current sensitivity. Similarly, voltage per unit deflection V equal to IR by theta. Sorry, a small mistake here. That is, here the equation is not this one. Deflection per unit current. Theta by I equal to NAB by C. This is called current sensitivity. Now similar way, here if you consider deflection per unit voltage is called voltage sensitivity, that is theta by IR. Now that is nothing but current sensitivity by resistance or NAB by RC. This is the current sensitivity and voltage sensitivity of a galvanometer. So they can ask question based on these formulas, like direct formula based question. But most of the time they will ask that how a galvanometer can be converted into voltmeter and ammeter. Like first thing, how to convert a galvanometer into voltmeter. Let's take, there is a galvanometer having resistance G, and it can give the current Ig for the maximum deflection. So that to convert it into voltmeter, we need to connect one shunt resistance. So when you connect a resistance in parallel, that is called shunt resistance. So that sorry, voltmeter, right? Voltmeter means not shunting. We will connect to convert galvanometer into voltmeter. We need to connect a high resistance in series. That means if this is the galvanometer and you are connecting some resistance R in series, then the net voltage across it will become V, where V equal to, here the current is Ig. So Ig into R plus G. So the resistance to be connected in series R will become V by Ig minus Z. So you can convert that galvanometer into a voltmeter of range V. Now similar way, when you want to convert a galvanometer into ammeter, like here this is the galvanometer and the maximum deflection current is Ig. Then to convert it into ammeter of greater range, then you have to shunt it with some low resistance. Let's take S, and here current is I. So that here Ig will go and here the remaining current I minus Ig will go. So that both are connected in parallel means the voltage must be same across shunt resistance across galvanometer. So that I minus Ig times S equal to Ig into G, so that the shunt resistance to be connected to convert it into ammeter is Ig into G by I minus Ig. Then you can convert the galvanometer into an ammeter of current range capital I. So this is how the formulas will be there, very simple formulas based on which questions can be asked. Now here let's take few questions. The coil of a moving coil galvanometer has an effective area of 5 into 10 power minus 2 meters square. It is suspended in a magnetic field of 2 into 10 power minus 2 Weber per meter square. If the torsional constant of the suspension fiber is, so torsional constant means C, that is 4 into 10 power minus 9 Newton meter per degree. Now find its current sensitivity in degree per microampere. So now they are asking current sensitivity, that is current sensitivity is NAB by theta, because the formula is NIAB equal to C theta. Deflection per unit current NAB by NAB by C. This is the current sensitivity. Now the moving coil galvanometer has an effective area. A is given. So A value is how much? 5 into 10 power minus 2 meters square. And magnetic field is 2 into 10 power minus 2 Weber per meter square. And torsional constant C value they have given as 4 into 10 power minus 9 Newton meter per degree. Then they are asking current sensitivity in degree per microampere. But here they have not given number of turns. So you have to consider as a single coil only and you have to substitute the value. So N value how much we have to take? Only 1. So that you will get the current sensitivity, that is deflection per unit current. But here you have to take in terms of microampere. So first you calculate and then multiply with 10 power 6. Then you will get the per microampere, because per micro means 10 power minus 6. If it goes up, 10 power 6 will come. So now the next question is, A current of 5 ampere is passed through the coil of a galvanometer having 500 turns. So the number of turns are 500 and each turn has an average area. Area is 3 into 10 power minus 4 meter square. If a torque is 1.5 Newton meter required for this coil carrying same current to set it parallel to a magnetic field, then calculate the strength of the magnetic field. The torque tau equal to NIAB. Now, the current in the coil is 5 ampere they have given. Now here, parallel to the magnetic field. That means, if a torque is required for this coil carrying same current to set it parallel to magnetic field. So coil is parallel to magnetic field means this is coil and the field is parallel means the angle between magnetic moment and field direction is 90 degrees here. Because magnetic moment means it is perpendicular to the plane of the coil. So that you can find the magnetic field that is from B equal to torque tau by NIA. So all the values are given. So torque tau equal to 1.5, number of turns is 500, current is 5 and area is 3 into 10 power minus 4. Then 3.5, 5.1. So then the magnetic field will become, so 0.1 by here 5 into 10 power minus 2. If it goes up plus, so 10 by 5, so 2 Tesla it will come. So this way, you just try to understand the question and try to apply the suitable formula. Now here comes the question like a galvanometer of resistance. That means the resistance of the galvanometer capital G value converted to a voltmeter of range V value 10 volt. By connecting a resistance, the resistance R equal to 10 kilo ohm, nothing but 10,000 ohm. The resistance required to convert to galvanometer, the same galvanometer to ammeter of range 1 ampere. Now, from this one, V R equal to V by Ig minus G. So, based on this formula, you can find Ig value. What it will become? Ig equal to V by R plus G. So, V is 10 by R plus G is 0, 100, 10,100, 0, 0 cancel. So 1 by 1, 0, 1, 0, 1010. Now, the resistance required to convert it into ammeter S equal to, now the formula is Ig into G by I minus Ig. Now Ig value is given, capital G is given and I value also given how much? 1 ampere. So that if you calculate, if you substitute and do the calculation, then you will get the shunt resistance. So try to substitute and do the calculation properly. Practice every calculation twice, thrice, so that your fastness and perfection both will increase. Now, the resistance of a galvanometer is 50 ohm and current required to give full scale deflection is, that means Ig is 100 microampere and galvanometer resistance is 50 ohm. In order to convert it into an ammeter for reading up to the current range to up to which it has to be converted 10 ampere, it is necessary to put an resistance of, so shunt resistance they are asking. That means Ig into G by I minus Ig. Just you have to take care of the calculation properly. Like here Ig is 100 micro 10 power minus 6. G is 50 by I minus, so 10 minus. So Ig is 10, 100 micro means 10 power minus 4. So approximately if you take, you will get the answer very easily. Like this value approximately 10. Then 100 into 10 power minus 6 into 50 by, you can take 10. Because it is 10 minus 0.0001. Nothing but 9.9999. So it is approximately equal to 10. In that case, 0, 0 cancel. I can write it as 5 into 10 power minus 4 ohm. So you take the approximation, then it will be good. Now, a moving coil galvanometer converted into an ammeter reads up to 0.03 ampere by connecting a shunt of resistance 4R across it, and ammeter reads up to 0.06 ampere. When a shunt of resistance R is used, what is the maximum current which can be sent through this galvanometer if no shunt is used? See, a moving coil galvanometer converted into an ammeter reads up to 0.03 ampere by connecting a shunt of resistance 4R across it, and ammeter reads up to 0.06 ampere when a shunt of resistance R is used. What is the maximum current which can be sent through this galvanometer if no shunt is used? No shunt means current is Ig, no shunt. But they have given that, see, I minus Ig into S equal to Ig into G. In that, if you write the equation for I, so I equal to Ig into G by S plus Ig. Now this value they have given like when you connect with 4R, that means Ig if you take common, so G plus S by S equal to I. Now first they mentioned that Ig times G plus S by S equal to 0.03, where S value is 4R. So this value is 4R. Now the same current value, that is Ig into G plus S, where S is R, then the current is 0.06. Now they are asking what is the Ig value. So here how many equations we have? 2 equations we have. And how many unknowns we have? Here we have, but here in the question capital G is also not there. So now whenever we have the 2 equations, we can add, we can subtract, we can multiply, anything we can do. So here if you divide both the equations, you will get that G plus 4R by 4 into G plus R left side equal to 0.03 by 0.06 will come. So equal to 1 by 2 will come. Now if you cross multiply it, 2G plus 8R equal to 4G plus 4R. So that 4R equal to 2G and G equal to 2R. Now you got capital G in terms of 2R. Now you take this equation and substitute, where Ig times G is 2R plus R by R equal to 0.06. Then it will become Ig into 3R by R equal to 0.06. RR cancel. So Ig is 0.02. So this way, here the question is little bit application type, not like direct question. Even if you want, you can divide the equation from this equation itself. So depending upon the given condition, you need to make the equations and you need to manipulate the equations. So sometimes the question can come based on the formula directly. Sometimes we may have to apply the little manipulation needed depending upon the question, so that you will understand. And here I have given the assignment numericals based on the same concept. So please try to solve all those questions. And also here 2 questions are there from the NCERT also based on the same topic. So thank you all of you. We'll continue in the next class. Thank you all of you.